My name is Saiter. I'm PM at Microsoft, working at the Fabrica Spark team. And today we're going to see which is the data science experience within Fabric. Actually, I'm going to talk about three different things. So hopefully you're going to learn a little bit about what data science will offer within Fabric. Then I'm going to mention some of the experimental features, the roadmaps coming in. And then we're going to talk about Copilot. So you may heard a lot about Copilot during some other sessions, but we're going to talk about it as well. Before starting, who has any experience with Azure ML or Databricks here doing ML? 1, 2, 3, 4, 5. OK. So let's start by talking about the data science process, right? So everybody here, I want you to understand which are the steps involving data science process. Maybe you're using a different process, but typically we start by defining a problem, what we want to solve, right? We have some data sets, maybe some tables within the lakehouse or ADLS2 in whatever format. And we want to do some kind of exploratory data analysis using Notebook, Pandas, and that kind of stuff, right? So we want to find outliers. We want to see data quality before starting building the model, which is part of the data discovery and pre-processing. Then we enter the inner loop of experimenting and creating our machine learning models. Normally, after we finish the data exploration, we just clean up the data set that we want to use for training the ML model. And we start maybe testing out different ML models or classifiers there, right? So you can be using random forest, for instance, which is a type of machine learning model for binary classification. At the same time, you can be using other types of classifiers for doing the same. And you're trying to see which is the accuracy of the models, right? So trying to evaluate which is the accuracy of the model so you can actually say, look, now I'm going to move to the next stage, which is enrich and operate. I'm going to put that model, and now I can use it so I can get some predictions. Potentially, those predictions can go back to the delta table in the lakehouse, right, or to a data set. And then I can also use Power BI to visualize those predictions. Let me give you a quick example using cuts. OK, so we're from the Fabrica. So anyway, I'm going to use this example. Sorry for that. I could also use dogs, but anyway. So let's imagine that you have kids, and kids has built a lot of Legos, a lot of animals with the Legos, right? So they have built dogs, cats, elephants, whatever animal they have. So you're wondering, at some time you have at home a lot of animals there, but you want to say, look, we want to just keep at home cats, right? We just want to get rid of the rest. So for that, you say, oh, OK. I'm going to do some data discovery and pre-processing. So I'm going to check all the Lego animals that they have. Maybe I have some duplicates because I have some kids doing the same, Lego animal. So I want to just keep the right Lego animals for my training data set. So this is where we start, doing what we call feature engineering. What does it mean is by just taking the Lego animals sample, we're trying to figure out which are the features that we want to bring for the ML model, like the size of the Lego animal, the color, that kind of stuff that we want to introduce to the ML model to run the experiments. And after that, we just create the ML model, and we can actually say, oh, once we got a pretty good, classifier saying, is this a cat? We can actually put it in an upper, and in a server layer. And we can use that in a Power BI report. So we can have this is a cat, this is a dog, this is a cat, this is a dog, right? Let's come back to Fabric now. Imagine that you have a Power BI data set. And you have a bunch of tables, dimension, fact tables there. But you want to actually enrich that with a kind of an ML model and to do a prediction. So you potentially may end up by creating a lakehouse, create a notebook using SymPy. I'm going to talk about it later. So you do some kind of data discovery and pre-processing. After that, once you have the clean data set, you may actually use Data Wrangler or Synapse ML. We're going to talk about it as well. And MLflow as well. What is MLflow? Just imagine that MLflow is just a site where you can log in a structured way, like PVIP, right? So in a structured way, with whatever metadata format, all the experiments that you're running for your ML models. So we support MLflow. I'm going to talk about it, and we're going to see in a demo later as well. Once you have that, you select which is the best model that you want to use. So you can use the predict syntax to just run a prediction, get the result, and then log that result in using a delta table and use back again direct lake so you can actually visualize in a Power BI report. Yeah? So this is just a super simple example about the end-to-end data science process, about the inner loop that as a machine learning engineer, data scientist, you may be following up within Fabric. So how can you get started with data science on Fabric? The easiest way is using what we call it workflows. I'm going to show you how to create a workflow. So if you follow a workflow, which is basically a template, it's just, I would say, a given tutorial where you can actually run, and it will create, you will follow all the steps that they show you in the data science process. Okay? So let's do that. I'm going to go to Fabric. Okay? So in this case, before going this, not sure if I heard about Fabric APIs, but I love Fabric APIs. I love automation. Okay? So I'm going to show you how to create a workspace. I'm going to create a workspace. I'm going to create a workflow from scratch. Okay? So in this case, we have Fabric APIs, and you can create a workspace. So instead of creating a workspace manually, I'm going to create a workspace using the Fabric API. Okay? So this is my VS Code. In this VS Code, you can see it here, right? So this is the payload that I'm going to send. So display name, capacity ID, a description, right? So this is exactly what I'm going to send to the API to just create a workspace. Okay? So on top of the API, I just love automation, that kind of stuff. So I have built a little tool in here. So let me check if this is available. So seems it's working. So now let's create a workspace. So first of all, I need to go back to my VS Code. I'm going to change the name. So live 4. Okay. And now we're going to run this. So basically what I'm going to do is I'm going to do a post, okay, to that particular URL, which is workspaces. And this is the JSON. Sorry, I'm going to do it bigger. So this is the JSON file that I show you. So if I run this, I'm calling the workspace API, right? You can see here the URL, and this should work. And I got a 201. That means that now, if I list the same Fabric API, guest, URI, and workspaces, you will see here that I got the new workspace created, the one that I specify. Okay? So I just want to show you this because probably in different sessions you have seen like creating a workspace manually, creating a lakehouse manually, creating a notebook manually, creating an ML model manually. But this is also possible. Okay? So if I go back to the UI now, you will see that my 04 workspace has been created. So let me go here. Okay. So let me go to the Fabric workspace. I'm going to refresh this. Sorry, I need to do this. Sorry for that. So you will see now that I have my Fabric 04 workspace. So I'm going to use this. Still, workflows are not supported in the API. So that's why I created a workspace through the API. And now I'm going to create a workflow here manually. So for that, I need to go to the data science experience here, toggle here, down here. Okay. And I need to go, so I'm going to do it this way. So I'm going to click data science, and I'm going to click on use sample. So when I click a use sample, we have 2 different tabs here. So the first one is end-to-end workflows using Python. And the second one actually is using R. So in this case, what I'm going to do is I'm going to create a customer churn workflow. And this basically is going to create a notebook with an end-to-end sample that you can follow all the data science steps, all the data science process. Okay? So I just created. Here, something that I will mess is creating a lakehouse and attaching a lakehouse. But I already create a workspace before for this. So let me switch to my workspace. So this is the workspace. As you can see, I created this notebook before. So this is exactly the same notebook that was created when I click Create Workflow. So I'm going to open this. I'm going to go to View. Not sure if you're familiar with this feature, but there is a way of table of contents, which is super handy for checking which are the different sections of a notebook. So I'm going to click here. You can see that these notebooks actually contain some of the steps that we were discussing within the data science process, right? So we have data cleaning, data exploration, which is called EDA, exploratory data analysis. Then we have model training and tracking. We have evaluation. And at the end, the step number 6 is the one that we can connect a Power BI report to a Delta table to just visualize the predictions as well. First of all, I'm going to introduce the 2 steps here, and later we're going to see the rest in detail. So first here, I'm just loading the data. So let me go here. So here, nothing really fancy. So we're using a public data set, okay, with some churn data. And then I'm dumping this data set to the lakehouse. So let me scroll down, and you will see that we're dumping this CSV file here to the lakehouse file section. So if I run this, I have run this multiple times. You will see if I go to the lakehouse, to my lakehouse, so where I have it here, yeah, so maybe I need to, yeah, okay. So I have here my lakehouse. Loading lakehouse, churn, raw, and you will see that my data set is here. Okay, so you can see my CSV file here, right here. So if I go back to the model, to the notebook, I just create a data set. Let me show you again table of contents here. And now I'm going to show you what kind of data exploration I did. In this case, I checked the churn CSV data set, and I see for 3 different things. The first one is, which are the columns that I want to keep in my data set, right? So for instance, I have customer ID. Do I need to keep it for my ML training? No. Do I have any duplicates? And is the data quality good enough for my data machine learning models and experiments? No. So this is exactly what I did here. So I did a exploratory data analysis. I'm going to come later with Data Wrangler as well. So basically what I did is I removed some of the columns. I removed the duplicates, so you can see here. I removed some of the duplicates and columns that I don't need in the data set from the raw data set that we created. And I also determined which are the key attributes that I want to analyze, right? So I want to see which are the categorical, numerical attributes that I want to see here. So this is also exactly what I have done here, determining which are the attributes and how they look like. Okay, so before jumping to feature engineering, here what I want you to understand is basically I run a workflow, and this workflow contains all the data science process steps, and we have seen how to load data and how to do some kind of exploratory data analysis just to ensure that the data set that we have in the lakehouse, we fully understand it, and we really understand the features that we want to introduce later in the feature engineering process. Let me come back to the deck now. Cool. So we have seen using Python for exploratory data analysis, right? So cleaning data, removing columns, removing duplicates, ensuring that we have good data quality on the data set, and so on. We can do the same with Data Wrangler, okay? So instead of using code-based approach, if you're more on the UI-based approach, the same you can use on Data Wrangler. So this is right now available. We have it available for Pandas data frame and also Spark data frames. So if you are creating data frames with a Spark, we have a public preview feature that you can actually use Data Wrangler for that as well. So I can show you here. So let me go back again to the notebook. Okay, I can go to data, and I can click. So sorry, I didn't run this notebook, so maybe it's here. Okay, because the session was. Oh yeah. So you can see here that I have a bunch of Pandas data frames created as part of the notebook execution. At the same time, I can actually query the Spark data frame. So for instance, let me click on the clean data frame. And you will see that I will be able to do kind of data exploratory analysis and data cleaning as well, instead of using Python and ampersand tildes, etc., using a UI tool which is called Data Wrangler. Okay. Let's move on. So we have seen Data Wrangler. Now let's jump to MLflow. So as I mentioned, as part of this inner loop, the first step was, hey, we have a problem. We want to actually create a model for that. We have a data set. We're going to do data exploration. We're going to clean up the data set. Now we're going to enter the inner loop. So we have cleaned up the data, and we need to actually specify which are the models that we want to use, and which are the algorithms that we want to use to solve that particular problem. So we support MLflow within Fabric natively. So that means that you can actually log all the experiments that you're running with your training data set using MLflow, okay? I'm going to show you in a bit how to do that. At the same time, once you have created the models, you can also use those models and use this predicate predict to just predict. That means that you have actually created a particular models, and you have some rows in another data set, and you want to actually use those rows for evaluating the model, right? So you are actually using the predict statement to send those rows, that data set, and sending back to the predict predicate, and that will actually answer you with the result of the prediction using the model. This is how you use, if the ones that are actually using Azure Machine Learning, and if you have previous Azure Synapse experience, this is the same predict predicate, okay, that we have on Azure Synapse and Azure ML integration. However, since we want to actually simplify this a little bit more, you don't want to use predict within your code. You can also use the UI. Okay, so there is a wizard that you can actually do the mapping about the input data set that you want to create the predictions from, and then do the mapping. And this wizard will also provide you a way to get the predictions. How you can launch that? So you go to Fabric. And again, in this case, I created different models. So first of all, let me explain you that one. So we cover loaded data, exploratory data analysis. I want to show you how I was doing the model training and using MLflow. Okay, so here I was, running some experiments. I have used 3 different binary classifiers, random forest with some features and some tuning. Secondly, I also use random forest, but different configuration. And then I use another classifier type. So I want to actually specify or check which is the best, out of 3 that is giving me the best accuracy. And for that, I'm using the MLflow to start all the experiment based on the training data set and the features that I select. So I can actually determine which is my best experiment. after I run this, so basically, let me go back here. So during the model training, I have run this for the random forest, option number 1, with 4 different features. In this particular example, I have run random forest also with 6 features. And here I just use light GVM, another classifier type, also to test the accuracy. Once I run these experiments, within the data science experience in Fabric, you'll see that I have different artifacts types, okay? So we talk about the notebook, but what about the, the experiment and also about the ML model on the left-hand side? So now, since we have run MLflow run, okay, and we just test out 3 different type of classifiers, if I go to my experiment, the notebook automatically create the experiment, and when we run MLflow run, those experiments are being logged within the experiment item or artifact. So if I go back to my experiment, which is this one, you will see that almost 1 hour ago, I have run this notebook and run experiment using 3 different classifiers. Random forest number 2 with 6 features, random forest number 4, right? And also light GVM. Okay, I talk about PVAP, and that MLflow also provide us a kind of a template of how the experiments are being logged. So in this case, if I go to the model, and if I zoom in, you will see that all the experiment has the same exact structure within it. So I have a requirements TSD with all the dependencies. I have a YAML and blah, blah, blah. And the model is packaged in this extension. If you're familiar with MLflow, it's called PQL. Okay, so in this case also, I can go to the experiment. I can see the accuracy of each of the models. So this is the accuracy score test for the light GVM. So you can see 0.86. If I go back here, this is the random forest. So the accuracy is different. And if I click on random forest 1, the accuracy is different. So at this point, I may have a little bit of understanding about how the different ML models look like, and which is the one performing. And once I create that, I will have handy my ML models as well. So not only the experiments item, but you will see that for every single run, I will have the different versioning of all the models that I create, in this case 3. Let me go back here. Cool. Okay, so in the experiment, I have used Python, but as you have seen also in the UI that we also support R, right? So you want to use R, we fully support R as well. Before jumping to the last step of the workflow, which was, how I can create the predictions, and now I can use those predictions in a Power BI report. Let me introduce a couple of libraries that we have. The first one is Synapse ML. Not sure if you're familiar with it, but this is also a library that you can use not only in Fabric, but also you can install outside Fabric, okay? So I provide you a URL here. So this provides different algorithms like a light GVM, the binary classifier that I show you in the demo, and so on and so forth. It comes with MLflow support, native integration with Azure AI services, cognitive services. So if you want to integrate with those as well, and also integrates with OpenAI service. The second one, maybe you're more familiar with it, I know, which is SymPy, okay? So in this case, this is the latest version. We also support Pandas and Spark for SymPy. So in this case, once you create also the delta table with the prediction, you potentially may understand that, and you create a semantic a model. You potentially may use SymPy to analyze that as well. Okay. So which are the common features within the data science experience in Fabric? I'm going to mention two. The first one is real-time scoring. So I mentioned that we support batch scoring, which means you cannot send just one row to the prediction, right? So you need to send a batch data set. So in a bulk, you will get all the prediction. What real-time scoring will provide is just like the API, is just an endpoint where you can actually call out, right? And you want to have real-time predictions, you will have an endpoint available to call once you create the ML model. Is that clear? So this is in the roadmap, and hopefully we'll be shipping this soon. The second one is AutoML with FLAML. So FLAML is just a Python library that supports AutoML. So we pretend to support AutoML with FLAML on Fabric and also with the Spark. This also integrates with MLflow. OK, so let's jump to the third part of the session, which is AI and Copilot. So maybe you may have seen some of the Copilot experiences in other sessions. But basically, this will have you doing three things. First, I use it also personally every day, ChatGPT. So it's like it helps me also to, speed up some of the things that I have in mind. And if I want to do something or test it out based on my domain knowledge, it helps me a lot to be more productive in that way somehow, right? The second one is AI-driven insights, like data science or data engineering experience within Fabric. You can open Copilot and just ask questions, and it will bring you insights, right? It want to tell you things, right? So based on the prompt. And the third one is generative AI on your data. A quick example is how I can enrich my data set with OpenAI, right? So maybe I have two columns in a data set. I want to add a third one. I want to enrich the data set using the OpenAI integration as well. So this is where AI comes into place within OneLake and the different experiences we have in Fabric. So we announced the Copilot in Microsoft Fabric, which basically includes three different Copilots. The first one is Copilot for Data Factory, okay? Which actually, you describe the transformation that you want to use or do using NL, natural language, and it will, it will provide you and assist you on that particular transformation. So in this case, I have a recording demo for my colleague Alex that I will show you an example here. Let me know if you can listen.
In this video, we'll explore how to enhance your creativity and productivity when authoring Gen 2 data flows. To get started, we'll use a starter prompt for inspiration to understand more about our query and any steps that have been applied. In this example, we've learned that the source is Northwind and the rows have been limited to only customers in the USA. Since we want to focus on orders and their details in this customer region, we will first join the two order tables together into a new query. A term like join, which is titled merge within Power Query, is easily able to be inferred. Now we'll limit our rows to only those where the ship region is in the USA to ensure consistency with our customers table. In the Copilot pane, the visual cues and titles on the cards, such as filter rows, are designed to help new or inexperienced users understand the keywords they can type or the buttons to click. After scrolling through and inspecting data in the data preview grid, we want to focus on the shipper name and regions and their total quantities. This results in a group by operation now being applied in a total sum of our quantity column. We'll now change the region name to abbreviation using a text input, and then update the query title in the visual diagram view. This ensures an augmented experience where simple things like renaming things can still be accomplished with ease and based on the user's preference. Leveraging the power of Azure OpenAI, we'll now ask for a query with state names, abbreviations, and Federal Information Processing Standard state codes. In the past, this would have required us to open a new browser tab, search for a website with a supported HTML table, create a new query with a web connector, and then apply necessary transformations. But now, all of this can be achieved via text input, increasing the author's overall productivity. Continuing to enrich our data, we'll join the FPS table and the US orders table together into a new query. We can further shape our table by asking it to move column positions and update all column headers to a more readable format by adding spaces with a single input. For many, updating column headers is a tedious task that must be performed one at a time, but is now possible in just a few words. Reviewing the data in the preview grid, we now see that a space has been added to each column. And in this last example, Copilot will assist in creating a rich calendar table for us by applying over 20 steps. In the past, this would have required numerous clicks, but with Copilot for Data Factory and Microsoft Fabric, it's done with just a few words. We hope you've enjoyed this overview of how Copilot for Data Factory can be leveraged as an AI-powered intelligent assistant that helps you focus on the task at hand and accomplishing complex tasks with ease.
Awesome. So I hope that this gives you a glimpse about the Data Factory Copilot experience within Fabric. Let's move on.
In this video,
I mentioned that we have 3 experiences. Okay. The second one is Copilot for Data Engineering and Data Science. Okay, which actually could help you not only to better understand the data that you have, so it has data awareness, but also kind of help you on the code developing while you're developing, for instance, a notebook, right? So we saw before, I was doing some kind of data exploration. What if I know the data set really well, and instead of using the code or UI data wrangler, I can use natural language to ask questions about the data set that I have on my lakehouse, right? So this is the kind of scenarios that opens up with Copilot here. For this one as well, I have a little demo. So I think that this morning my colleague Luke showed a demo, but hopefully this will also help you understand it better.
Let's take a look to see how we're integrating Copilot for data science. Here I am in a notebook with the same e-bike rental data that we've been working with. I've loaded some data frames, and I could start writing code manually, but let's see how Copilot can help. Let's open up the Copilot task pane. I'm going to collapse this pane over here so we can see more of the notebook. And let's get started. Right away, I have some suggested prompts to help me understand my data and how to analyze it. Let's ask to see some suggestions of how to visualize things. I get a good list of options, and I could ask Copilot to help with any of these. First, I want to just get a basic column chart of trips by station. All I need to do is ask Copilot for help. I can enter my prompt, and Copilot looks at my data and generates the code for me. This lets even someone who's just getting started with Python to get up and running quickly. Now that I have the code, I can insert it into the notebook and run it. Right away, I see that the San Francisco Caltrain station has the most trips starting from it. That's interesting, but now let's ask to get a heat map of trip duration between start and end stations. Again, Copilot is going to take my prompt and generate the code for me. Let's insert it into the notebook and run it. And now I have a pretty interesting heat map. There are a few outliers which we can zoom in on, and it looks like San Jose State University has more long trips starting there than on average. And as you can see, Copilot is doing a great job of just letting me ask questions and taking care of providing me the code so I can just play with my data. Now, asking questions from the task pane is okay, but I'd rather work directly in the notebook. Fortunately, I can use Copilot in a notebook cell just by typing %% code. Let's ask for help creating a forecast for next month using the Profit Forecasting library. Copilot has generated the code. And you can see it takes quite a bit of know-how to know how to use this library. But Copilot has taken care of figuring out how to use it with my data. So now I can just run the code. And just like that, we have our forecast. Let's look at the shape of the data by asking Copilot for some visualizations of the output. And now we have a line chart of our new forecast. I could keep iterating and playing, which is really fun using Copilot, but let's finish off by writing the results back to my lakehouse. Copilot is going to truly democratize the ability for everyone to be able to work with data in advanced ways. And as you can see, Copilot gives everyone a bit of data science superpowers with Microsoft Fabric.
Awesome. So again, I hope that this quick recorded demo gives you an idea about what you can do with the Copilot experience within data engineering and data science experience on notebooks. And now let's move on to the last one, right, which is Copilot for Power BI. In this case, maybe you have seen different sessions, but you can actually, again, use ML within the Power BI to define metrics or calculations or whatever, or get insights using ML as well. I just skipped the demo here, so I have a demo, but hopefully maybe you have seen on the internet or in other sessions as well. Because I want to mention another one that the team is working on, which is Copilot for OneLake. So OneLake is just the center of all the experiences within Fabric. So we have like a different compute engines on top, and then we have OneLake. If we put it AI in the middle, then we can also use AI on top of OneLake. Why not? So there are like different ways of doing this. I briefly mentioned one before, which is using Synapse ML library. Synapse ML library connects directly with the OpenAI service. So in this case, you can use Synapse ML to also live with the data that is on your lakehouse or OneLake. This is the first option. The second option that is in the roadmap and we're working on is, how to embed the experience within not only Fabric, but the rest of the M365 and Azure AI Studio as well. So basically, the OneLake could be the central piece, or the glue to integrate with those. So this is just an example of a Q&A integrating within a team chat, and it's going to give you some answers about the data that you have on OneLake. Actually, I have a quick demo on that one, and I'm going to show you right away. So I'm going to turn off because, I want to explain you a little bit. So again, just take it as a experimental demo, something that the team is working on as well. Let me run the demo. Awesome. So in this case, this is a preview feature which is called AI skill within the data science experience in Fabric. So you create an AI skill, okay, which is a new item type. Still, we're not sure about this will be the last naming or the last naming convention. But you can create that, attach a lakehouse. So in this case, VentureWorks. And you will have a prompt. So in this case, you just attach a lakehouse, select which are the delta tables that you want to actually query, right? And now I'm going to open actually the prompt to start asking questions. So here I'm just giving some of the context to the Copilot. And now I just going to ask, what is the most sold product in this, selecting just these tables. So as you can see, So it gives me a result, but in this case I'm saying, look, I'm going to give you some feedback, right? So what most sold should be on the total sales volume, not order quality, right? So I'm just giving a hint about where you should be looking, and it's providing me another selected statement on that particular one. Again, here trade-offs. What will be quicker, right? If we know the table, just running a select or using natural language to do that, right? So there are a lot of trade-offs about the possibilities that how we can use this, right? So we can use code, we can use the UI, we can use the natural language to actually ask questions and get results. Okay, so I'm gonna let like a 5-6 minutes for questions. Here, just a recap. What I wanted to explain to you, which are the features based on the experiments, the ML models, and the notebooks that we have within the data science experience in Fabric. I show you how to use the workflows. So you want to just quickly jump in. I would really recommend using the workflows because you will experience all the steps of the data science process and just start learning on that one. But we also have tutorials, right? So you can go step by step, guide tutorials, which are the steps, probably for, if you want to get started as well. If you're missing any features, I think that Chris mentioned, we have ideas for them. So please do jump in, go there, and whatever features you're missing, we're happy to also see there and just So yeah, I'm open to questions. Please. Yeah, so the question is if the real-time scoring kind of endpoint will be exposed within the Spark or within the workspace level, right? So it's going to be exposed at the machine learning model item as you are doing the batch scoring, right? So if you're familiar with Azure Machine Learning, right, you have pipelines there, you have models, right? So basically when you create a real-time scoring model, it's going to provide you a URL, right? And you will go to the machine learning model item within Fabric. You will pick up the URL. And then as you are using with the rest of the REST APIs, you can actually pick up the URL, right? And you can actually make a request to do the prediction, and you will get the result. But that will be at the machine learning model item part. Yeah, thanks. So this is like comes also handy, right? So we run on trust, right? So I'm gonna mention a couple of things. Sorry, I need to repeat the question. Totally right. So the question is how responsible AI principles are being applied here, considering that for institutions and some, risky data, let's put it that way, when we're interacting with Copilot, how we manage that, right? So I'm gonna mention a couple of things here. I think that Luke also mentioned this morning, right? So the first one is the data boundary. So if I'm spinning up a capacity, right? I'm attaching that capacity to my workspace. When I'm using Copilot and the prompts, which is basically the tokens, will that go out of my boundary? The short answer right now is yes, right? Why? Because we don't have still the region mapping between all the regions that we have available in the capacities and all the GPUs we have on the OpenAI service, right? So basically, Copilot is using OpenAI GPUs, right? And right now, we are still lacking that kind of region parity or mapping between the capacities, and so that's the first one. The second one is the prompts that you're using, right? Those will be logged by OpenAI for some time. I think that is, if I'm not wrong, it's 30 days. But we are working on that, so those could not be actually logged by the OpenAI service. That means that you're using Copilot, and if you just log a prompt, that prompt will go to the OpenAI service and will be logged there, right? So they can potentially use that metadata, right? So, but we're working, right, to just get, so that could not happen. So we also ensure that not only the data, but also the metadata is actually kept somehow within your data boundaries. And I think that the last one is more about, responsible AI and how your data is protected, right? So I think that we are fully committed to that within Microsoft, and I would say that that's not a choice. So yeah, I'm not sure if I answered your question. Yeah, thank you. Okay, I want to just finish the session saying thank you, thank you, thank you. I know that is the last session of the day, so I really, really appreciate you being here. I will appreciate also the feedback, so I put it here if you can scan it. So yeah, and see you around. Thank you.